In this first example in section 1.4, we're going to look for the cube roots of I. In particular, the polynomial equation z cubed minus I is 0 is degree 3. And the degree should tell us, the degree being 3, should tell us that we should have at most 3 roots. And in this case, actually, we have exactly 3 roots. And so what we're looking for are sort of the cube roots of I, right? That's another way of saying exactly the same thing. We want to find them. Now, with polar form, we can derive a formula for what these cube roots of I are. And it's done in our book, so let me just write down what they should be. So in the notation of the book, WK is going to be the nth root of R, and I'll quantify what these are in a minute. Cosine of theta plus 2 pi k over n plus I sine theta plus 2 pi k over n. And this is for k is 0 up to n minus 1. And this is for a z that looks like r cos theta plus I sine theta. All right, so in our setting, r is equal to 1, because that's the modulus of I. In our theta, we can take as the argument, we can take pi halves, because I makes an angle of 90 degrees with the positive real axis. N is 3 because we're looking for cube roots. So we have sort of our first root, which is going to be the cube root of 1. This is the real cube root. This is the real root. And then cosine of theta plus 2 pi times 0 over 3 plus I sine theta plus 2 pi times 0 over 3. Cube root of 1 is 1. This is cosine pi 6 plus I sine pi 6, because this term goes away, and pi halves divided by 3 is, of course, pi 6. Now, we can compute this, our first cube root of I. Cosine of pi 6 is root 3 over 2. Sine of pi 6 is a half. And notice that for W0, we'll do W1 and W2 here in a minute. If we were to draw the unit circle, I is, because why the unit circle? Y is unit modulus. And we were to mark I, this is W0 at root 3 over 2 plus I over 2, or I times a half. And notice when you, again, multiply W0 with itself, you're going to go another pi 6 around to 2 pi 6, which is pi thirds. And then when you do a third power, you get to I. So you sort of walk there. So here's W0 squared, and then this is finally W0 cubed. So it does in fact work. Now W1 is a similar formula. I'm not going to write the cube root of 1 this time because it's understood that cube root of 1 is 1, at least the real cube root of 1 is. And then we do pi halves plus 2 pi times 1 over 3 this time, because our subscript is a 1 now. Plus I sine pi halves plus 2 pi times 1 over 3. Okay, so let's do some arithmetic here. Pi halves plus 2 pi, I believe is 5 pi halves. And then this is also 5 pi halves. And then we're going to go ahead and divide that by 3. So that's cosine of 5 pi 6 plus I sine of 5 pi 6, which is equal to, in this case, negative root 3 over 2 plus I times a half. Scroll down a little bit here. Let's draw another picture so we can get a handle on what this W1 is. Again, we're going to draw our unit circle. And we're going to mark I, and then W1 is over here. Now, when we square W1, we're going to just move another 5 pi 6 around the circle. And that should put us about here, W1 squared. And then when we cube W1, it's going to move us another 5 pi 6 around the circle, up to there. So that is, in fact, another cube root of I. And if we sat here and we cubed this out, we would recover that. Now lastly, W2, again I'm going to avoid writing the cube root of 1. It's a similar formula, cosine pi halves plus 2 pi times 2 now, over 3, plus I sine pi halves plus 2 pi times 2 over 3. So that's 4 pi plus pi halves. I believe that should be 9 pi halves and 9 pi halves. Although you should double check my work. I make mistakes. So that's cosine of 9 pi 6, because we divide by 3 again, and plus I sine 9 pi 6. So let's see, we've got 3 pi halves here, just to simplify a little bit so we know exactly what the angle is. 3 pi halves is 270 degrees, cosine of 270 degrees is 0, and sine is -1. So we get negative I. All right, let's finish this example by drawing our third picture of this other cube root of I. It looks like this, and then the one that we found is down here at negative I. So every time we take a power of W2, we have to go around 270 degrees. So 270 degrees around is going to put us, boom, there. -1 on the real axis. That's our W2 squared. And then another 270 degrees around puts us up here at I, W2 cubed. So that is another cube root of I. And if you sit here and you actually do the arithmetic, the algebra, and cube each one of these, you'll see that you get I for each one of those.